three branches in an electrical network can be connected in number of forms, but most common among them is either star or delta form. If three branches is connected to a common point like neutral to form a symbol like Y, then that connection is known as star connection. When three branches are connected back to back to form a triangular, then that connection is known as delta connection. In delta connection we don't have the neutral, but these star and delta connections can be transformed from one from then another for simplifying complex network. Now let's see star to delta and delta to star transformation step by step. Now let's see the delta to star connection. Okay, if you convert this delta circuit to the equivalent star circuit like this, then that is known as delta to star connection. Here we know the RAB, RBC, RCA all delta values, and we need to find out the star values like RA and what is RB and what is RC. These three values we need to find out, right? We already know irrespective of the connection like star or delta, the equivalent resistance between any two points like A or B or B or C or C or A is equal in delta and either star also. Means if you take the delta connection, the point A to B equivalent resistance is equal to the same point A to B in delta connection. Okay, for example I am taking the points A and point B. So from point A to B, if you observe this point between A to B, here in star connection only this RA and this RB is connected to A and B point, but C is not connected here. Okay, here this C is connected to this C point, but for A point RA is connected, for B point RB is connected. That's it. And these two are in series nature, right? Series connection, cascaded connection, because this end point is connected to the RA starting point. So that is the connection. Okay, so if you take this two equivalent, then that will be RA plus RB, right? Then that is equal to, and coming to the delta connection, here delta connection is this RAB, right? So if you take the point from A to B, here this A point is connected to the RAB and also this A point is connected to RCA also. Okay, and this B point is connected to RAB and this B point also connected to RBC. Here these three are connected in delta connection, but in star connection only RA and RB is connected. Okay, so if you look at this delta connection, this RBC and this RCA and this RBC are connected in series, right? This ending point is goes to the starting point, then these two will be the series. Okay, and these two will be the parallel to this RA. Why? Because here this RA starting point is connected to this RBC starting point, and this RAB ending point is connected to again this RBC ending point. Means if you add these two as the cascade. Okay, now if you simplify, this RAB is parallel to this RCA plus this RBC cascaded circuit. Okay, this is the final equation you are getting from the points A to B. Now if you further simplify, we know the formula of equivalent circuit in parallel network, that is nothing but 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus so on, right? So if you calculate the equivalent resistance of this parallel, then you will get the 1 by R equivalent, right? Means 1 by RA plus RB, that is equal to this RAB is parallel to these two series connected networks, right? So then you will get the 1 by RAB plus what is the second resistance here? 1 by this RCA plus RBC. Now if you further simplify these two, then you will get the 1 by RA plus RB is equal to, if you cross multiply, then you will get the RCA plus RBC into plus RAB divided by RAB into RCA plus RBC. That's it. Now take this RA plus RB this side and this whole equation to this side, then you will get the RA plus RB is equal to RAB into RCA plus RBC, that divided by RCA plus RBC plus RAB, right? So now take this equation as equation number 1. So up to now we are taking only from A to B equivalent resistance only. Okay, so like this, if you also take the equivalent resistance between this B and C also, right? Okay, here in B and C, B is connected to RB and C is connected to RC. Here RA is not connected and these two are series connection. Okay, so do the same process, then you will get the RB plus RC, right? And that is equal to what? Here for RA and RB, you will get the RAB into RCA plus RBC. For B and C, what you are getting? You are getting the RBC into RAB plus RCA. That's it. Like above equation. And that divided by same. RAB plus RBC plus RCA. Okay. Now take this is equation 2. Now if you take the equivalent resistance between this A point and C point, then you will get the RA plus RC, right? So now do that one. Like above equation, take the term RC plus RA, that is equal to RCA into RAB plus RBC, that divided by same as it is RAB plus RBC plus RCA. That's it. These are the equations you are getting. Okay, now just add these three equations, 1 plus 2 plus 3 equations, then you will get the here RA plus RB, RB plus RC, RC plus RA, means here 2 RAs you are getting and 2 RBs you are getting and 2 RCs you are getting. That means 2 into RA plus RB plus RC, and here all denominators are equal, right? Then you will get the RAB plus RBC plus RCA. Okay, and here coming to the numerators, if you multiply each term, then it will goes to RAB into RCA and RAB into RBC. Like this also RBC into RAB and RBC into RCA and RCA into RAB and RCA into RBC. Here also you are getting the two terms. Okay, then you will get the 2 into RAB RBC plus RBC RCA plus RAB RCA, then that divided by RA plus RB plus RC. Now these two and these two is cancelled. Then finally you are getting the equation like RA plus RB plus RC is equal to RAB RBC plus RBC RCA plus RCA RAB divided by RAB plus RBC plus RCA. Okay, now take this equation as equation 4. Okay, now just subtract this equation 4 and equation 1. Then what you are getting? Here RA and RB and RC is there. If you minus 1 means RA and RB, means RA and RB and RA and RB cancel, then finally remaining RC. Okay, so that RC is equal to, here these denominator and these denominators are equal, then finally you are getting the RAB plus RBC plus RCA only. Okay, and coming to the numerator, so here RAB into RCA, right, and RAB into RBC. So RAB into RCA cancelled and RAB into RBC cancelled, and remaining RBC into RCA is there. Okay, so RBC into RCA is there. That's it. This is the equation you are getting the RC. Here RC means what? In star connection you are getting the value of RC. That's it. So like this, if you subtract this equation 4 from 2, then you will get what? Here RA, RB, RC is there, and here RB and RC is there. Here you are getting the RA value. RA is equal to what? Same denominator, same RAB plus RBC plus RCA. Okay, and coming to the denominator, here RBC into RAB and RBC into RCA. Here these two and these two are cancelled. Then finally you are getting the RAB into RCA. That's it. This is the equation for resistance RA. Okay, so here RBC and RCA and RAB values are delta connected values. Okay, this is the delta connected values. Okay, but we don't know the values of RA, RC and RB. So if you replace this RBC and RCA values to RA, RB and RC, that's it. That is the transformation of delta to star, right? So like this, subtract this fourth equation to third equation like this equation, then you will get the remaining term RB also. Okay, RB is equal to same denominator RAB plus RBC plus RCA, and you are getting the numerator like RBC plus RAB. These are the three equations you are getting. Now take these equations as equation 5 and equation 6 and equation 7. Okay, till now we just convert this delta form to star values like RA and RB and RC only. So now again we need to convert star to delta also. Now let's see star to delta transformation. In star connection, we know the values of RC, RA and RB, and we need to find out the RAB value, RBC value, RCA value. That is the delta connection values. Okay, till now only we convert delta to star connection. Now we can see how star to delta transformation. For converting star to delta, here we take the equation 5, equation 6, equation 7, right? Just multiply each equation like 5 into 6 and add, and again multiply 6 into 7 and add, and again multiply 7 into 5. Do this, then you will get the, if you multiply this equation 5 into equation 6, then you will get the RA into RB, right? Then here you will get the RA into RB plus, here what you are getting, equation 6 into equation 7 means this is RB, this is RC, then RB into RC, and again 7 into 5, 7 means RC, 5 means RA, so RC RA. So till now we just add and multiply left hand side only. Okay, now coming to the right hand side, first of all multiply these two and add, and again multiply this 6 and 7 and add, and multiply 7 and 5 and add. So then finally you are getting the RAB plus RBC plus RCA whole square, and coming to the numerator you are getting RAB into RBC square into RCA plus RAB RBC RCA square plus RAB square RBC RCA. Okay, this is the equation you are getting after multiply, add each two equations. Okay, so and further simplify, then you will get the, so here take common RAB, RBC and RCA. Okay, so if you take common RAB, RBC and RCA, then you will get the this RAB plus RBC plus RCA, then that divided by RAB plus RBC plus RCA whole square. This square term and this term is cancelled. Okay, then finally you will get the equation like RA RB plus RB RC plus RC RA, that is equal to, here these two are cancelled, right? Then you will get the RAB RBC RCA, that divided by RAB plus RBC plus RCA. So take this equation as something like equation number 8, but we need to calculate the this RAB and this RBC and this RCA terms separately, then only we can convert the star to delta conversion. Okay, so for that purpose just divide this equation 8 with each 5 and 6 and 7 separately. Means if you divide equation 8 by equation 5 and again divide equation 8 by equation 6 and again divide equation 8 by equation 7, then you will get the RAB and RBC and RCA values separately. Okay, so now first of all do this one, divide equation 8 by this equation 5, then what you will get, you will get the, so this is the equation 8, right? Now if you divide this by equation 5, then you will get, we know the equation 5 is what, this RA is equal to RAB RCA by RAB plus RBC plus RCA. Okay, now divide this one. Okay, so by 5 means RA, and this whole term divided by RAB into RCA divided by RAB plus RBC plus RCA, right? Here these two are cancelled. Okay, then finally you are getting RA RB plus RB RC plus RC RA by RA equal to, here RAB RBC RCA, right? Here RAB RCA and RAB RCA cancel, then finally you are getting only RBC. That's it. This is the equation. This RBC is one of the resistance in delta connection, right? If you take this is the delta and take this A and B and C, this resistance is in between this resistance. So that's it. You get the one delta connection resistance. Like that, divide equation 8 by equation 6. Then you will get the equation like RA RB plus RB RC plus RC RA divided by RB, that is equal to RCA. That's it. Now you will get the second equation. Like that, divide this equation 8 by equation 7. Then you will get the equation like RA RB plus RB RC plus RC RA, that divided by RC, that is equal to RAB. That's it. This is the final delta equations we are getting. Okay. These are the RAB values, RCA and RBC. These are the delta values we are getting. This is the transformation